Good day, fellow. Seto is back. Kindly, if you are new to this channel, don't forget to subscribe and also hit that notification bell so that whenever I upload videos, you'll be able to see them. Then firstly, today we are going to consider the concept of electrostatics. You see? Check, we have two ways. We have the term electro, we also have the term statics. Then what does the term electro means in this context? It refers to electric charges. Then now we have another one, static. It implies stationary. Then now the term electrostatic now it implies the study of stationary electric charges. You see, we have two, in fact we have three electric charges. Firstly, we have protons, electrons, and neutrons. See, then protons, they are positively charged, electrons negatively charged. Lastly, this one, they are neutral. See, these ones, they are neutral. Let me now consider electrons as well as protons. See, let's say now, let us start with the proton. Let's say if I have a proton like this, then somewhere there I have what? My electron. See, you just need to know that a proton as well as electron, they produce what? Electric fields. For proton, they always move away like this. They always move away. They produce electric field. Then electrons, they always move. Let me try to draw nicely. They always move towards. See, electric field. They always move towards. Then now, what does the electric field now means? What does the term electric field implies? What does the term electric field imply? It's a region of space in which an electric object now experience a force. See, an electric object experience a force. What I'm going to do at this point now is I'm going to consider two unlike charges. Let us take a positive together with the negative. They said here it's a proton, said here it's an electron. This one is a proton, this one is an electron. See, now let us consider two unlike charges. See, we have unlike charges. Let us try to draw the electric field around these two charges. Check. We said that they always move away from positive but towards the negative. Away from positive towards the negative. You see? Towards like this, but away from this one. You see? Eventually what is going to happen? They will attract each other because there is no space. Now let us consider like charges. Let's say if we have this one together with this one, somewhere here we have now, let me try to draw nicely like this. See, let us consider this one. Charges move away, same for this one, away. You see, away. What is going to happen? We see a gap somewhere there. They repel. Like charges, like charges, and like charges, they repel. Same applies if we had now negative charges like this. Sorry, negative charges like this. The electric field will always move inward or towards like this. Eventually what is going to happen? Like towards, even this side, towards. For this one, we said it's away. You see. Then we see the gap. Eventually what is going to happen for this one? Repel as well. See, what we have learned is that for two unlike charges, they attract. Like charges, they repel. Now let me consider if we had a point A somewhere there and point B somewhere there. Where do you think is electric field the strongest between the two? Is it at A or B? Clearly it's going to be A. Electric field, they are stronger closer to the electric charge, but they are weaker away from what? The electric charge. Get a point? At A they are stronger, electric field, they are stronger at A but weaker away from the charge. They are stronger closer to the charge, weaker away from the charge. Yeah. Now what I'm going to do is let me erase firstly. Let me erase. Let me erase here. Okay, yeah. What I'm going to do now is we have three different ways that we can use to charge some object. You see, let us consider sorry, let us consider a case whereby if let's say I had two, let's say if this one was neutral charge, let's say this one is neutral, then let's say this one is negatively charged. Let's say it has 4 electrons. It's negatively charged. Yeah, it's negatively charged. Then firstly, we are going to allow these two charges to be in contact. You see, to allow them to be in contact. You see, what is going to happen if we allow these two objects to be in contact? That's the first thing that you should know, that we can charge another object when we allow them to be in contact. By contact, we can charge by allow them to be in contact. Say by contact, we allow object to touch each other. It's like now if I were to allow a neutral together with a negatively charged object. Let's say if these two spheres were exactly the same, then on that note, what is going to happen is the electrons, these electrons will spread around these two evenly. You see, will be spread like evenly like this. Then after some time, if we allow these two to separate, each is going to have a negative charge. You see, check. At first, this neutral, this one was neutral, but now after it has gained what? 2 electrons. You see, it's no longer neutral, but now it's negatively charged afterwards. This was before, then after. It's negatively charged. You see, we can charge object using what? This method of contact. By contact, allow them to touch each other. Secondly, by friction. By friction. It's like we rub now. You see, allow object to rub. It's like we rub, allow object to rub each other, or somehow we rub two objects in this one. Let's say now if we had, let me consider a cloth. Let's say if we had now a cloth, I don't have a space. What I'm going to do is let me erase let me erase so that I can have enough space. See, say this one is neutral. See, let's see if we have now let's see if we have two objects, this one which is neutral and this one which is somehow negatively charged. Let's see if this one is negatively charged. Let's see if this one was a rod. See, say this one, if it was a cloth. See, then now we are going to consider number 2, charge these two objects by friction. You see, we allow them to rub each other, or as we rub them, you see, allow to we allow objects to rub now each other. See, it's like what I'm going to do is we are going to consider this one to be neutral. Then now here we have a rod like this. You see, it's like if I take this rod, then brought it closer, to this cloth, then we rub it. After some times, what is going to happen is some of electrons will be left on this cloth. You see now, some of electrons will be left on this cloth. Then from neutral cloth, we now have a negatively charged cloth. You see, then this one is also negative. I wanted to explain that when we rub two or object, electrons will move from the one it moves to the other one. See, then thirdly, now we are going to consider an induction now. An induction. Let's say if I have two sphere with plus, minus, minus, then somewhere here I have a negatively charged object like this. Then thirdly, if we allow to charge this object by induction. See, for induction, we allow objects to move, closer to one another, but not touch. See, but not touch. It's like now if we brought closer these two charges, a neutral charge with the same proton and electron, this one is negatively charged. Check what is going to happen is, before we have a situation like this, see, before, let's say it's like this, then now let's bring closer these two, but they should not touch. See, what is going to happen is these two electrons, they will repel each other. Then these two positive charge, they will move closer. Then we are going to have a situation like this. You see, these two charges, they will move closer. The positive charges will move closer, then the negative charges will move closer. But we don't allow these two to be in contact. You see, then things have changed. You see, things have changed. Then we call this one an induction. It's like we brought them closer, but they should not touch. I thank you.